This is a lesson teaching you how to solve two-step equations, and we're going to start with some guidelines for solving equations. Now, you won't always use every single one of these in this topic, in this section, but it's just a guideline of a kind of like a checklist of what you should look for and complete in order. Again, it's a guideline, it's not required. The first step is to use the distributive property if needed or if you desire to. And we are actually going to hold off on that step until section 2.3, where I teach you how to apply the distributive property. So for this section, we're going to skip that step, but that should be the first step you do. After using the distributive property, or if you don't need to, you should always then look to see if you can combine like terms. Remember that like terms have the same variable with the same exponent. So if you have something like a 4x plus a 7x, you would want to combine those terms to get 11x. Once each side of the equation has the like terms combined, you move on to step 3. And step 3 is to get the variables on one side of the equation using addition or subtraction. Remember, it's all based on those properties of equality that say you need to use the inverse operation to get rid of things. Moving on to step 4, we need to get rid of addition and subtraction using inverse operations. So if you're trying to get rid of addition, you would need to subtract. If you're trying to get rid of subtraction, you would need to add. Once the addition and subtraction is gone from the problem, we move on to step 5, which is getting rid of multiplication and division using inverse operations. At this point, the only thing left to do would be to simplify your answer if possible. So those are the 6 guidelines for solving any kind of equation. You will not always use every single step, but you should go in order and ask yourself if you need to use each one in order. So let's go ahead and get some examples done. Example 1. The first thing I'm going to look for is the distributive property. Like I said, we're going to skip over that one in this section. The second one, the second guideline, is to combine like terms, and we don't have any like terms. I'm going to draw my line like I always do when I solve equations. And if I look to the left-hand side, I have x over 6, which means x divided by 6, plus 9. There are no like terms there. If I look on the right-hand side, there are no like terms there, so I move on to step 3. Step 3 doesn't apply to this because it says to get the variables on one side. We have the variable x. It's already on one side of my line, so step 3 doesn't apply. Step 4, we need to get rid of addition and subtraction. So I see that I have addition here with the x, so I have to get rid of the addition by using its inverse operation, subtraction. So I'm going to subtract 9 from each side. The plus 9 minus 9 is 0, so that cancels. I'm going to drop down my x over 6, so that comes down here to x over 6. And then on the right-hand side, I have to add or subtract -1 minus 9, which is the same as -1 plus -9. Either way you want to think about it is fine. And we get -10. The next step in my series is to get rid of multiplication and division. So remember that that bar, x over 6, means x divided by 6. So I need to get rid of the divided by 6 by doing the inverse operation, which is multiplication. So I'm going to multiply both sides by 6. 6 over 6 is 1. So now I'm left with 1x, which is my objective. And then on the right hand side, I do negative 10 times 6, which is negative 60. And now I have my answer. The last thing I need to do is see if it simplifies. Negative 60 doesn't simplify, so I am done. Moving on to example 2, I'm going to go a little bit faster. The first guideline doesn't apply. The second guideline doesn't apply, combining like terms. And the third guideline doesn't apply because we have the variable on one side of the equal sign already. So I'm going to get rid of subtracting 6 by adding 6 to both sides. The y minus 5, or I'm sorry, the y over 5 drops down. The minus 6 plus 6 is 0, so that cancels. And then I have 3/10 plus 6, which is 6 3/10. The next step is to multiply both sides by 5, since I'm dividing by 5. The 5 over 5 is 1, so I'm left with y. Now, in order to multiply a mixed number times a whole number, we need to change that mixed number to a top-heavy fraction. So let's do 6 times 10 is 60, plus 3 is 63, and that's over 10, times 5 over 1. And hopefully you understood the prerequisite information that I taught, where we're going to look to cross cancel. So if I look to cross cancel the diagonals, 5 goes into 5 one time, and 5 goes into 10 two times. So I get 63 on top, and on bottom I get 2 times 1, which is 2. So there is my answer, 63 over 2. And the last thing I need to look at is, does it simplify? And there is no number that goes into both 63 and 2 evenly. So 63 over 2 is a perfect answer. Some of you would want to change it to a decimal, and you are allowed to do that. If you wanted to do that, that would be 31.5. Alright, moving on to a word problem now. This problem says a rental company rents a luxury car at a daily rate of $42.85 plus 34 cents per mile. Jenny is allotted $90 for car rental each day. Write an equation to represent the cost C of renting a car and driving X miles. And after we do that, we're going to find how many miles Jenny can travel on $90. So we have to think the cost is going to have to equal the amount of money we have to pay to rent the car, so that's the daily rate. Then we have to add in the 34 cents per mile, so the cost per mile, multiplied by the number of miles I drive. So if we start plugging numbers in, it says the cost, C, so we're going to use C for cost, equals the daily rate, so that's $42.85. We have to pay that no matter what, And then we have to pay for the cost per mile. So we have to pay 34 cents for every mile. And we don't know how many miles we drive. So we just put an X there because we don't know how many miles that is. So this is the equation that represents the cost C. Now let's figure out how many miles I can drive with $90. So I'm going to plug in $90 for the cost. I have the $42.85 plus the 34 cents times the number of miles which I'm looking for. So there's my equation that I have to solve. Let's draw our line. There is no distributive property used, and there is no combining like terms because we only have one x in the problem. And step 3, we do not have to get the variable on the same side. So we're skipping all the way down to step 4. We're going to subtract 42.85 from both sides. And you are certainly welcome to use a calculator to do this. 90 minus 42.85 is 47.15. So the 42.85 cancels there. And the 34 cents times x drops down. Step 5 is to get rid of multiplication, so I'm going to now divide both sides by 0.34. And when you do that, you get a messy number. $47.15 divided by 34 cents is 138.676471, and it continues on. So I'm going to go ahead and round it to 0.68. And make sure on digits you read the directions, and it will say what to round to if you need to. So that means that I can drive about 138.68, or I would say probably 139 miles for the $90. So this is the first page of your notes. I will continue the second page in a second video.